Ladies and gentlemen, please welcome our next speaker, Peter Parsons, presenting the topic, Policy as Code for Any Cloud to Any Edge Automation.
Good morning, and welcome to DevOps Pro Europe. Thank you for all taking the time. Oh, good grief, more coming in. Strange environment, slightly different to the one I was in yesterday. I do like watching stand-up comedy, just to go off on a tangent, and I do this, so just be warned. And the stand-up comedians, I go and say, always tell me how bad it is with the lights shining in their eyes and you can only see the first two rows. And I think right now I understand just how they feel. So those of you at the back, I've got no chance of seeing what you're doing back there. So anyway, on to the talk. Thank you. Good morning. So Peter Parsons, I'm based in the UK, but work for the chef business within Progress Software as a technical pre-sales engineer, supporting customers all across Europe, including some here in Lithuania. So delighted to be back. I was last here about 6 weeks ago. Enjoy visiting Vilnius and the region. So one thing as well, I think it's worth getting clear before we start. One thing I'm not is I'm actually not a developer. I haven't seriously cut any code for a long time, since the 1990s, and back then I was a fairly serious C hacker, writing compilers and stuff like that. But that was another lifetime ago. What I do have is a background in the infrastructure side of the industry, infrastructure software, hardware, networking, virtualization, container platforms, and all of that side of it. So while I appreciate this is a DevOps conference, one thing I learned many years ago from one of my university lecturers is that is not to constrain yourself in terms of what you can do in software or hardware, because you can do the same things in both, and also think about how you can apply that, because DevOps isn't just about application development, as hopefully I'll be able to show. So, quick summary, what I'm going to cover, a little bit of a overview of the state of the market, some of the things that we're seeing as an infrastructure vendor rather than a pure play DevOps provider, and then talk a little bit about how those ideas, principles and theories can be applied beyond the realm of application development, because they absolutely can and they absolutely should. So, the market today, a whole bunch of stats there. I'm not going to go through all of them. Suffice it to say, this industry constantly changes. Back when I started out, clouds were things that you saw in the sky and were responsible for the rain. If I wanted to go and check my bank balance, I had to go into the middle of the town where I lived between 9:30 and 3:30 Monday to Friday, walk into a building and go talk to a person. It wasn't 5 seconds and a couple of clicks on one of these things. The world is evolving, and by the time I hit retirement age, and certainly looking at my audience here, by the time most of you hit retirement age, I have no idea what the world's going to look like anymore in the tech industry. Suffice it to say, the one thing I can guarantee is it's going to be different from where we are today. Back when I started, things were pretty centralized. The traditional data center approach, connecting via terminals, was how a lot of computing was done. If you went into that bank branch I talked about, then they would have 80 by 24 character terminals, green screens, orange screens, for those of you who may remember those things. Pretty simple interface, keyboard, couldn't do much with them. A mouse wasn't a thing. It was just a standard basic QWERTY keyboard. The world has moved on so much in the decades since, and one of the big shifts and the big changes has been the amount and the volume of data that is now generated. I probably have more data sitting on that than some of those data centers had back in the late 80s and early 90s when I was starting out in the industry. And increasingly, we're generating more of that data, and that data itself is living out there on those devices. Think about an autonomous self-driving car. How much data does that need to do what it needs to do and to do it safely? It certainly wouldn't work if it had to try and connect back over a network to a central data center every time it needed to make an instant decision. Whereas the first car I had, probably the only digital device in there was the radio. Everything else was mechanical, literally. So, the state of how we compute, the state of where we compute, is very much changing. Data out in the wild, outside that traditional safety net of the enterprise firewall, is at more risk, and in the modern social media world, the chances of that data, one, leaking, and two, putting the CIO, the CEO, the CISO all over the press is much greater as well. Again, back then that wasn't really a thing, because let's be honest, nobody had the technology at home to go and try and break into that bank and get any of that data or steal any of their money, as happens today. So the world has changed very, very much. And with it, there's been a change on how we do things. Now, I did start over here, way back when, doing things by hand on a terminal window. If I needed to do something to half a dozen systems, that meant logging into half a dozen terminal windows and typing the same thing 6 times. And I was great at typing things 6 times, because we all know we can repeat and we can do it perfectly. So I'd log in, I'd type in the same thing 6 times, and I'd done a perfect job, and I ended up with 4 systems that were exactly the same and 2 that were different in 2 different ways, even though I'd typed exactly the same thing 6 times, right? Because we can't do that. It doesn't work. And that's only for the small networks that I used to look after back in the 1990s. Let's say back in another lifetime. So where solutions like Chef, and there are others out there, and I've been in this industry a fair amount of time, and even though I work for a vendor, I'm very happy to have open conversations about the state of the industry and the swings and roundabouts, and I've worked with other solutions as well. And especially just double checking none of my sales colleagues are here, so I can say what I like. Great. The industry's evolved and started off, with Chef. If anyone's familiar with Chef and its history, it's about 15 years old or so now as a company and as a product and as a solution. And it was there to enable consistent and repeatable and scalable configuration management of, at the time, virtual machines, physical servers, giving you the ability to actually define the state of your environment in a coded way, in a repeatable way, so that rather than you having to go on and work manually, you just express how you want your systems to look, and Chef would basically build them for you to your requirements. Moving on from that, as a solution, we added about 5 or 6 years ago a compliance and testing solution in there to enhance that, give you some repeatability, not just in how you build, but how you prove that what you built is what it should be. And for those of you who are working in regulated industries, I've worked a lot with, being UK based, worked with a lot of financial services organisations over the years and still do. Banking is heavily regulated. So are other sectors like healthcare. On and off, I've done a lot of work with the online gaming industry. That has some very interesting regulations that you have to work with. So it's not just about building to a standard, it's about being able to prove that you've built to a standard. So being able to show that you're not just where you need to be, but you can demonstrate that compliance is key. And all of that feeds into where we are and are looking to go, which is to have everything in your environment, all your policies expressed as code in some way, so there's nothing manual within your environment. So what does this journey look like? Where have we come from, and where are we trying to get to? So, infrastructure as code, the start point. As I said, back in the 90s when I was configuring the infrastructure manually on the servers, configuring the network involved getting real cables and plugging them into real sockets on real switches, rather than, again, configuring everything in software. Kind of worked, as long as you didn't make any mistakes. But yeah, as it says up there, let's press the right button. Error prone, because I'm a human being, I'm error prone, I make mistakes. And it's not a particularly scalable approach. I'm not a 24/7 resource. I do occasionally need a bit of time off and some sleep. And coffee, definitely need coffee. So the idea behind the infrastructure as code piece here is essentially, your infrastructure can have developers in the same way that applications have developers. And those developers define the state of an environment, the state of a network, the state of a server, the state of an application to be deployed, using a language and a framework in exactly the same way that you build end-user applications or business-to-business applications, using exactly all the same tooling here. So you have a code repo for your infrastructure, probably the same code repo you're using for your applications. Be sensible. Goes through the same pipelining process, goes through the same test harnesses potentially, using that compliance testing as a way of proving it, and then can be pushed out and deployed wherever you want to run. So that's the basic principle behind what Chef does, what Chef was originally designed to do, and where it's looking to go. So the benefits of this. There are a number. I'm sure most, if not all of you, are familiar with the term shift left. Again, industry term. We love as an industry inventing terms and coming up with ways of saying something, but in a way that's unique to us, so we kind of can keep the rest of the world out from it a little bit. Shift left, yeah, very simple. If you have a problem, fix it early when it's a small problem. That's all we're doing. The earlier you fix something, the easier it is, the cheaper it is, and the less of a problem it can, well, down the line it can become a bigger problem, and you really don't want to run into those bigger problems because they are more challenging. So the idea behind infrastructure as code is you can develop and test your infrastructure, deploy your infrastructure, and guarantee the state of your infrastructure in exactly the same way as the applications that are running on top of it. And it's provable in the same way from a compliance, a regulation, a validation perspective as the applications that are running on top of it. So how do we do that? And how do we do that validation? The compliance as code piece here is about taking us away from this approach where security didn't come in until you had an application to review or a system to review. You've gone through, and I'm old enough to remember when waterfall was the way all software development was done. And here, each of these steps here was a handover. we did as a company, organised somebody to look at a study and look at information transfer and information loss in that model. So every time you make one of those handovers, how much of what's here actually ends up here in terms of information? And the study found the answer was about 50%. That may sound not great. It's also not that surprising, because whenever we do something, so much of the understanding of what we do and how we've done it and why we've done it is in here. It's probably not documented. That's again, not the greatest. So we know why we did that way rather than that way. We know the little detail behind why something's been set up in a particular way that it is. But that doesn't always get communicated, and sometimes it's so obvious to us we think it might be obvious or should be obvious to everybody else, and often it's not. And that detail gets lost in those communications. So you imagine here we lose 50%, 50%. How much in production by the time we've got that 50% loss every time? How much of the information we started with and the knowledge has actually ended up over there? It's less than 10%. It's not great. So not the ideal way to go about things. So with the compliance as code, and we talk a lot in Chef not just about DevOps but about DevSecOps, and DevSecOps is all about making security an equal partner in the whole process, and making sure that the security team are involved right here at the start, so that we don't end up running back into that challenge where by the time we get to this, we realise we've done a whole load of work with something that's not going to pass here. We have to go back to square one and down again. Now we have a big problem. That's an expensive problem to fix. We've wasted a lot of people's time. And it's not a great situation to be in. So by integrating security into the processes, and if we go back to that first chart I had with the state of the industry, a lot of organizations are already doing that. If you are, great. If you're not, please think about it. You know, it's a great way to improve things further and make sure that when you hit that end stage, you're going to get there quicker. You're not going to have to go back around the loop. And secondly, because everybody's been involved all the way through the whole process there, that information and knowledge loss from stage to stage is going to be reduced or minimized. I mean, ideally we want it eliminated. Doesn't always happen, but that's where we want to go. Increasingly these days, most organizations, not all of them, are making use of public cloud as well. There are very good reasons why public cloud is a real asset to the industry. Going back 10, 15, 20 years, organizations, had large data centers. When that data center got full, the marginal cost of adding one more server was crazy, because you needed a new building, you needed new power supplies, I live in the UK, you needed lots of planning permission and regulations to go through. That one more server, the server itself may have been only a few £1,000s, but the actual cost of bringing that server into your environment was in the millions, or even the tens of millions sometimes. If you've ever been to the east side of London, it's full of lots of data centers. They have a power problem. There isn't enough power. When we were, as a country, building all the infrastructure for the London 2012 Olympics, as was, that actually had an impact on the IT industry because the amount of power they needed for the building work, for the infrastructure, for the Olympics, took power away from the rest of the grid. The data centers were limited. Actually, even the London Underground slowed down because there wasn't enough electricity to run the trains at full speed. So these things do impact on us. So the real benefits of cloud, the agility, the flexibility. The ability to comply with some of those regulations I talked about earlier. Anything to do with financial transactions, anything to do, as I said, I've done work in the past with the gaming industry in terms of where gaming transactions happened, where their customers live. There's lots of regulations around that. A lot of them are non-technical regulations as well. So if you have anything to do with the US and the gaming industry, that's done on a state-by-state basis. So if you've got a customer in North Dakota, that means certain things must physically happen in North Dakota. There isn't an awful lot of data center space in North Dakota. It gets quite interesting with some of these environments and some of these challenges. But increasingly there is. So organizations are making use of cloud, multiple clouds for geographic reasons, for regulatory reasons, and just more than anything else, just to give themselves choice. One of the reasons to go with more than one cloud provider is to avoid being tied into any single provider. Now, I work for a software vendor, and I've worked for a number of vendors in my career. If you look at my profile on LinkedIn, you'll see it's a history of various hardware and software vendors over the years. And one of the things I got told very early on in the industry, useful snippet, and I always happily share this with organizations I talk to, is that my job as a vendor is to make it as easy as possible for you to adopt the stuff that I'm talking to you about. Okay? I want you to buy my hardware. I want you to use my software. My job is to make it easy for you to do that. As an organization who's buying software, your job is to make it as easy as possible for you to go somewhere else when you've decided you don't like my software anymore. Okay, so if you're in the business of choosing software, or involved in the process, or looking at the process, make sure you always factor that in. I'm using this stuff now, but if next year I want to go somewhere else, how easy is it for me to go somewhere else? I want to make sure I can go somewhere else. You should always be looking to do that. That's the best thing for your organization to do. Don't be tied in to any one organization's stuff. And that's why a lot of organizations look at multi-cloud, because they can play the pricing off against each other, they can play the technical features off against each other, and it just gives them that flexibility. The challenge, or one of the challenges with cloud though, is it's out there, it's outside the data center. How do we manage all the challenges associated with giving people access to something that's outside our data center? What do we do about our data sitting somewhere that's outside our data center? One of the things the clouds are very good at is making it very easy for you to get your data into them, and maybe not quite so easy to get it out again. If you look at the small print on the pricing, always something to be aware of. What are my users doing here? What rights do they have? Have I given them rights to do the right thing? They're spending my company's money. Have I got control over that? CFO will certainly be interested in that one. How's my storage configured? Publicly accessible S3 buckets seem to be a pretty common thing in terms of data breaches and leaks. Should be something that's fairly simple to avoid, yet seems to happen on a fairly regular basis. So how do we avoid all this stuff and make sure that somebody in our organization doesn't put our organization at risk by making one of these usually simple configuration errors? It's usually a mistake, not always, but most of the time it's a mistake. And how do we do that when these things might exist across the world? If you look at some of the global organizations, and one organization that I've worked with in my time working with Chef was doing this across clouds spread all across the world geographically and looking at objects running into the millions. How do you prove the compliance of that many objects, which are then supporting their customers, and do so that you can be sure that you're not exposing your organization and your customers to potential risk? It's a real challenge. And that data is increasingly sitting in interesting and unusual places. So the size of the the wording here is kind of related to various studies showing where some of this data to actually sits. If we look at it, retail these days. Again, my first job, school job, part-time job when I was at school, was working in a supermarket across the road from the school where I attended. The tills were mechanical. Pretty much everything was done as a cash transaction. If it didn't, it involved writing a check. Credit card machines certainly were not a thing. Contactless payment. No, that was decades into the future. These days, you walk into a modern supermarket. When I go into the supermarket, the first thing I do is I pick up a device. I scan the device against my loyalty card. I then get special offers in the shop based on scanning the loyalty card. So they're now analysing me and going, what can we persuade him to buy this time that he didn't last time? Let's give him a deal. Let's get him trying to buy a little bit more. You go around the shop, you're scanning all the barcodes. Again, back then, barcodes weren't a thing. I had a manual pricing gun, and I'd put an individual label on everything. After I'd manually hopefully set the price correctly with my thumb. If I got that wrong, I was in real trouble. These days, there's none of that because it's all done using the IT systems in there. You go to the till. Again, the till's an electronic thing. Beep, beep. As we scan, everything's stored in there. That feeds the stock control system in the store. The stock control system can then contact the warehouse and say, we're selling a lot of ketchup or whatever it is this week. Please send us some more. We're running low. It's, the world's advanced so much in so many ways with all of this data. We have, one of our big users in the US is a restaurant chain. Again, interesting challenge. How do you manage organizations where some of these places are in the middle of nowhere in the US? So 20 miles down a dirt track road with a network connection that's not much better than dial-up. We have pretty good connectivity here in Europe. 5G, 4G, pretty much everywhere on our phones. Fairly ubiquitous Wi-Fi. So a lot of the world isn't like that. But this data is still out there and being generated because they have to give the same user experience in that store 20 miles, the shop, the restaurant 20 miles from anywhere, as you get in the middle of a big city. So the data requirement is fairly much the same. Lots of challenges. Aviation. As I flew in yesterday, the pilots were probably doing their pre-flight checks on a tablet. The passenger list will be probably on an iPad that the chief flight attendant has or whatever, and they can look at it and go, where are our frequent flyers? Who do we need to give special attention to? Does anyone have any special meal requirements? All of that's done now, electronically rather than the old-fashioned way of a big paper printout. For those who remember big paper printouts and dot matrix printers, again, don't know how many other people other than me in the room are of that sort of an ilk. So, how do we tie all of this together to make all of this modern complexity simpler? Well, the approach that we take at Chef and that we advocate is bundling it all into what we call policy as code. The idea being, doesn't matter what element of your environment you're talking about, your application, your infrastructure, your compliance checks, express it in a coded way, use exactly the same process and approach that you do for your application development. Use the same source code repositories, use the same version controlling, use the same pipelining. You can use the same sorts of test harnesses, so long as you can write the test for it. And wrong button. And you can bring everyone together, no matter what part of the business they're in, not just the apps, but the office of the CISO, your chief regulatory officer, and your infrastructure team, to build it all and bring it through to deploy fully consistently into production, and not just in your individual data centers, but out there on all those interesting places that exist outside the corporate data center as well. So, what does that bring? Well, in our view and our experience, these sorts of approaches do bring a lot of benefits to an organization. Efficiency, scalability are key. Pretty much every organization is in a situation where, as a phrase I've heard many times over the years, do more with less. How do you do more with less? There's only two ways. Well, there's only two ways to do more. One is to work harder. The other is to work smarter. One of those is a much more appealing approach to it than the other, and that's to work smarter. Because working harder just means more hours, longer hours, evenings, weekends, all of that sort of stuff. And to be honest, we all want to do stuff, not just work. So by coding everything, you've got audit trails, you've got provability, you've got repeatability, you can automate the testing, you can automate the deployment of everything. And for those people who in the business need to go out and prove it to an external body, living in the UK, organisations like the Financial Conduct Authority, the regulators, we've got a lot of them, the Office of something or other, Ofcom is the Office of Communications, they regulate telecoms, Ofgem, they regulate the energy industry. All of those bodies require the organisations that they regulate to be able to prove their compliance with the standards and all the other things with them. And this approach gives you the tooling and the information to be able to do that. So just to wrap up, we'll take questions. So, if you're not already taking the approach that you're using to build your applications and looking at how you can apply that to other areas of your organization, I recommend that's worth doing. And at that point, I'll stop talking. And we've got microphones down the front here. Don't know if anyone's played anything with Slido, but just to finish off, any questions, any discussion points? Like I say, none of my sales colleagues are here. I can be an open, as honest as I like. It's great. So do we?
Yeah, we can check like Slido, but I see. Okay, I said no questions, but now we have one question.
Okay. Perfect.
Yeah, here maybe I can read it. Could you please provide a specific example of policy as code?
Okay.
It's a bit hard to understand from abstraction. How does it shifter from?
I'll be different. Typo. S and D next to each other on the keyboard. Somebody has borrowed my fingers when typing. Because my typing is terrible, and the more people are watching me type, the worse I get. So policy as code. So it's really about what it is you're covering. So the infrastructure of code piece, that the traditional chef configuration management, and there are other tools out there. Like I say, no sales colleagues here. I'll be honest at that. We'll cover things like, this is the version of the operating system that needs to be installed. And then I'm going to configure things about my operating system. So what ports am I going to open in the firewall on the server? Which packages do I need to be installed? What version of those packages? What are the config files for those packages look like? If it's a web server, do I have a standard home page that gets deposited in there, or do I have other content related to that? If it's an application server, how's that configured? What does it relate to? If I'm going to deploy a database, how's my database set up? What's my defaults on the database and that side of it? So that's your infrastructure piece. And then you've deployed an application to go on top of it. Now, while that's running, how do we check the state of that? How do we prove that how we think the server or the instance of the application should be is actually the case? So we want to be able to run tests against that deployment outside of the deployment itself. So we don't ever want to mark our own homework if we can avoid it. So if we have a second framework, and Chef does this, and there are other solutions out there in the market that do the same thing, that can come in and look at that deployment and go, run a test. So, is this particular kernel module disabled, for example? How's my user access and user management configured in there? Do I have appropriate password standards that are compliant with my corporate password? So is the minimum length what it should be? Is the rotation policy what it should be? Is the complexity policy what it should be? Is the history length policy what it should be? What ports do I have open within there? And what protocols are they supporting? So policy as code is a broader encompassing than just your infrastructure. It's about running that security and compliance testing alongside it, and then being able to report back on that so that your business owners can go to the CXOs who need it, and they can go to the external bodies to need it and go, yes, we've done this, and this is how we've done the deployment. But more importantly, here's the proof. Because what the external bodies care about is they don't believe you, they want you to prove it. That's my experience. So that's what it is. Policy as code is a more broader, all-encompassing view of and covers more than it. Oh, I see there's another one come up. What stack do I recommend? So, if my salespeople were here, there's only one answer to that question, right? The honest answer is, there are multiple solutions out there in the market. So, number one, the whole stack includes everything. Not just the aspects that we do as Chef and our competitors do. So many of you, probably our biggest competitor on the configuration management side is Ansible, and I know Ansible as well. I spent nearly a decade working at Red Hat, so familiar with that as a solution. So from a stack perspective, is, again, also look at what you already have. So if you've got a lot of DevOps processes in place for your application, start from there. No point in reinventing the wheel. Definitely not. So, if you've got a source code repo, you've got version controlling, you've got all of those processes already in place, just, the same tech works for application code, for infrastructure code, for compliance code. No problem at all. You've got a pipeline, existing pipeline. Maybe you're using Jenkins, you're using Maven, whatever you're using. No reason to look to move away. Those same tools and technologies can be used, again, extending from just your application code to your infrastructure code to your compliance code. You need to write some different testing harnesses, potentially, or typically, to go through that piece. But, start with what you've got, would be my honest recommendation. If you've got something that works for you now for the application side, look to extend its use, improve its value. And then, look to where you might have the gaps, and then how you might want to do the configuration management, how you might want to do the compliance piece. And there are many aspects to compliance. It's a whole nother subject in terms of what you want to check. So from our point of view, we build and provide things like the standard CIS profiles, the standard DISA SIGs. Out of the box, what we don't do is vulnerability scanning. That's a whole other area as well. So you may need some tooling for that and automate that process as well. So yeah, the answer is start with what you've got, see where your gaps are, and then evaluate the tools that will help plug those gaps. So bringing into external body. Yes, that's part of, absolutely. In the UK, we have some quite heavy regulation in certain industries. Doesn't always work very well if you look at the news from the UK newspapers and see the state of some of our rivers and things like that at the moment. You go, well, maybe some of that's not doing well. That's not IT regulation. That's other regulation. But yeah, a lot of what external bodies want, they don't want to know that they want to know you're doing it, but they want you to be able to prove it to them. They want that you to be able to give you the rubber stamp to go, yes, you've said you're compliant with whatever our standard is. You've shown me I'm happy. You can carry on being a bank. You can carry on being a healthcare provider. Or whatever it is, because if a bank loses its banking license, it has a bit of a problem, and something similar. And I think I'm probably about to get the wrap up or the hook or whatever the thing is. So, thank you very much for being here. Thank you for your time. Thank you for the questions, and enjoy the rest of the conference.
Yeah, please guys, give a warm welcome and applause to Peter. Yeah, thank you very much. That's it.
Yeah.